Okay, thank you everyone for coming to this lightning talk. I'm going to keep it brief because I know we don't have that much time. So I'm Sophie, I'm a software engineer working in the open source social science space. I've got about 2 years of dev experience, so I'm coming at this talk from a very beginner junior perspective. Maybe some of you that are familiar with testing already call this like a rediscovery workshop, but it's very much a beginner friendly talk. So testing, what's it all about? This is a very famous quote by a software engineer called Kent Beck, who wrote a book called Test-Driven Development by Example. So essentially he came up with the idea that test-driven development is all about removing fear from the application development process. So in a nutshell, it's about writing a test before you write a function or a program. Okay. So these 4 people essentially represent who I have been over the last year. So the person on the left was me about a year ago, and I was invited to do a technical assessment for a role as a junior software engineer, and they asked me to write an application using TDD, otherwise known as testing. So I was like, okay, I've totally got this. And then when I got to the technical interview and I was pair programming with 2 senior devs, I was like, I really don't have this. I didn't understand it conceptually. I was completely winging it, and of course I didn't get the role. And I thought I'd never touch testing again after that. I was like completely traumatized by it. And then fast forward to now, I'm actually using testing every single day in my daily work. I love testing, as you can see. I can't imagine writing my code without it, but I want to stress that it is a journey. Like, it's very much a mindset as a developer, learning to test and using tests. It's not about like picking it up and suddenly understanding it and getting it. You probably will go on the same journey that I've been on, kind of understanding it, but you're not really doing it, and then you sort of get it, but then you're writing tests for like very basic functions until now, where I've built sort of like entire applications that are completely tested all the way through from beginning to end. So I'm going to run you through a very, very basic example of how this works in real life. So this is taken from an actual function, like a helper function that I've written in my code. Add one makes sense to everyone, right? So this is completely language agnostic, but I'm a predominantly JavaScript developer, so I'm writing this in JavaScript. I hope everyone can get the gist of what's going on. So you pass me a number, I want you to return me something. This is what I call the base case. So always start your test with a base case. Don't overcomplicate it with adding logic. Write your base case, which is simply, when I give you something, give me something back. So give me this number. Now we go to write the test. So we are using a particular testing framework here called Jest, simply because that's what I'm using in my code right now. We're building a React application, so Jest is very compatible with React. So we essentially use what we call an assertion. So describe the function, which is called add one. It adds 1 to a given number. So you just give it something that's really readable. It is another keyword in the assertion library for this particular testing framework. So what this basically says is, given this number 1, add 1 with this number. So pass me this number to the function that I've just written. And we have an expectation that this is going to return me 2. Now, of course, it's not going to return us 2 just yet, because we haven't added the logic in the test to say add 1. So when we say expect the result to equal the expectation, we're going to assume that this is going to return us a failing test. And look what happens. We start with a failing test. It says the test expected 2, but it only received 1. This makes sense to us because we haven't embedded the logic yet. So what do? We go back to the function and we tweak it. And we say, okay, now I'm going to add the function to the function, the specific tweak that's going to satisfy my expectation. So we're going to add 1, and hopefully, fingers crossed, we have a passing test. So ignore the number of test suites and ignore the number of tests, but this is actually taken from real code in my code base. But this means that because we've added the number 1, it's now satisfying the expectation, and we now have a passing test. And honestly, as a dev, that green light is like the most cathartic thing ever when you've been fighting to get your test passing all day. Okay, so this is just a quick overview of what we've just done. We've created a test file or a spec. A spec is just a technical specification when you're building tests. We invoke the function in the test file, we give it some input, we create an expectation, something that makes sense to us, and then we test against the actual output. Okay, so testing isn't for everyone, and I have to admit sometimes I cannot be bothered testing. I'm on a flow with my code, I'm writing a ton of logic, I cannot be bothered going to my test files and making sure that there's proof that it works. And as Kent Beck says, if you're happy slamming some code together that more or less works and you're happy never looking at the result again, TDD is not for you. I only half agree with this. TDD is for everyone, but it actually doesn't, it's not so important all the time. If you really just want to like spike something out, I probably wouldn't TDD, but it's completely context dependent. If you want to do it, great. If you don't worry about it. Okay, so these are some of the reasons why we actually should care about testing. So basically, the main three things that I want to point out here, planning out APIs. As developers, we work a lot with APIs, and this is a really good way to ensure that you have a clean API. So because you're having to consciously think about what your expectations are, you're building your library before it's built, essentially, through your testing suite. So it's a very kind of like imperative, declarative way of creating APIs. Refactoring is an amazing benefit here because once you get your test to pass, you essentially have like the proof that it works, so you can always go back and refactor to make it cleaner and more concise, but you can do that without knowing it's a breaking change, without making it a breaking change. Regression bugs as well, like when we add features onto code that was prior to that working, and then suddenly for some reason that code isn't working anymore, you're able to specifically pinpoint why, because you're able to test that part of the actual code base that has caused that breaking change. And then these 3 points are quite self-explanatory. The one that is really good for businesses, it saves time and money in the long run because you're not chasing bugs when things have gone into production and it's negatively impacting your user experience. Okay. So I'm just going to whiz through these because I know I'm running out of time, but you'll probably hear lots of jargon about testing, and to be honest, I find those super confusing. I'm still every day learning more about this topic, but the main things to remember are unit tests are like micro tests. So when you write a function like the one we've just written, that's a unit test. When you do integration testing, think of it as a broad scope. It's a complete like sequence of unit tests that don't need to be retested. Think about it in the sense that like you're going end to end, and you'll hear end-to-end testing as well, and the two things can be used interchangeably in my opinion. So to give you a real life example, I'm building a survey at the moment and I want to test that the user can go through the whole flow, and I want to know what happens when the user correctly inputs some values into my form and what happens when the user incorrectly puts those values in. I want to know what the happy path is and what the unhappy path is. I don't know what the other path is called, but anyway, I want to know what happens in both scenarios, and that's what I would call an integration test. And there's some very cool technology that helps with that. One of the things I'm using at the moment is Cypress, and if anybody uses it, I think you'll know how cool it is because it kind of looks like magic, the way it simulates like the user going through your test, your survey or your browser, and it like shows red and green, and it's just like magic. Anyway, I'm being geeky. Okay, so assertion libraries and testing frameworks, this is the main difference between the two. I find them also confusing to remember what each of them means, but a testing framework is the thing that you use to organize and execute your tests. So you might have heard of things like Mocha and Jasmine, they're very popular, and then assertion libraries is the actual thing that verifies that your tests are working. So when you see things like it and should and expect, that's your assertion library. Okay, so things to avoid, these are the pitfalls. Non-deterministic, flaky test, that basically means that when your code is written, when your test is written and it breaks for a reason that isn't, if your code hasn't changed and your test breaks, it's because your test is written in a way that is dependent on an external factor, on a dependency or an external library, and that is a flaky test. Your test should only ever return you a result based on your code and your code only. So don't ever if your code doesn't change, it should never change the output of your test. It should either pass or it should fail. It should not be a dependency that causes your test to change. Okay, so don't write multiple assertions in unit tests. That is the point. Keep them micro, keep them isolated, and then inversely, don't not write multiple assertions in your integration test. This was something that I learned very recently. I came from a very unit testing mindset, and I realized with integration, the whole point is that you just jam a load of assertions in there to see what the real user flow is like. So keep it as broad as possible when you're writing your integration test, so avoid repetition of what you've already done in your unit. Okay, so unreadable tests, that's an obvious one. Try and keep your tests as readable as possible by naming your variables well. And when you read your test using the assertion library that you're using, it should read in a way that a new developer that comes into the code base can understand what's going on when they read it. Tests can also serve as documentation, essentially. And these are my final tips. Practice, practice, practice. Like I did, I literally had no idea about testing a year ago. Now I'm using it every day. I'm stood here today talking with you about it. Create a function is your first place. Like, always create a function, keep it simple. Remember to give the baseline. So the base case, is when you give your function of input, let it return you that same output, take it to your test suite, create a test using a spec file, use whatever library, assertion library you want to use, it doesn't matter. Just get that test working and see what happens when it fails. It will inevitably fail on the first go. Go back to your test, go back to your function that you've just written, tweak it until it passes, and that is where the cycle begins. So it's essentially write the function, write the test, tweak, let it pass, and repeat. Okay, that's all, and thank you very much to our sponsors. And any questions, we probably don't have time, but feel free to catch me out there.